Hello everyone, welcome to this video. In this video, we have to answer this question which states that what can you say about a subgroup of D3 that contains R240 and a reflection F? If you remember, D3 represents the symmetries of a triangle, correct? So for a triangle, we could rotate it by 120 degree, we could rotate it by 240 degree and then by 360 degree, which is equivalent to R0. Or for a triangle, we can have a reflection about this axis or about this axis or about this axis, which we are naming by L1, L2 and L3, right? Okay, so knowing this thing, we already have drawn the Kelly table for this one, right? What is that Kelly table? The Kelly table for D3 is, we have written it like this. Here the operation is composition, correct? So here if we consider our subgroup S1, let S1 be the subgroup which contains R240, this is given to us, and a reflection, right? Let's take a reflection to be L1, correct? So that then in that case they have named this to be F. F could be any of L1, L2, L3 and a reflection F, right? Where let's say F is any one of L1, L2 or L3, correct? So in this case they are saying we have to find a subgroup which is generated by this R240 and F. So it should surely contain these two elements. If that is the case, so what would be our S1? Let's see what is this set. So it would definitely have R240 within it. It would definitely have we are taking F to be L1, right? Let F is equal to L1. So first reflection. So it would definitely contain L1. So what all elements would be there in this? So here you can see what is R240 composed with itself. So let's have a look. Here R240 in our Kelly table composed with R240 is R120. So that means R120 is definitely present here, right? So let's write it here. What about L1 composed with L1? Let's have a look. When L1 is composed with L1, you have R0 here. So that means R0 should also be present here, correct? For it to be a subgroup, R0 should be there, which is the identity element. What about R120 into R120? Let's have a look. R120 with R120 is R240, which is already present. So no need to write it again, right? It is R240 already present in S1, right? So what about R0? R0 into R0 is R0. No need to check for that. So let's check it for R240 into L1. What is it? R240 composed with L1. It is L2. So that means L2 has to be there in your group as well, right? So it is L2. So that means we have L2 also present here, right? So thereafter we can check what is L2 into L2. What is L2 composed with L2? So this is L2, this is L2. So you see we have R0. So no need to write it again, right? So R0 is already present within S1. So what else is left behind? We can check for R240 into L2. What is it? R240 is here, L2 is here, it is L3. So we also have L3 present within our group, right? It is L3. So you see, by doing this calculation, you have all the elements which are present in this D3. Hence, your S1 is nothing but D3, right? In the second case, if we assume that let S2 be the subgroup of D3 containing any two reflections, correct? So in this case, reflections. So we assume that let S2 be generated by L1 and L2. Now let's see what all elements would be there in S2, Again we'll be doing the same calculations. What is L1 into L2? Let's see in the table. L1 into L1 is R0, so definitely R0 is present with us, right? In S2 this is R0, so obviously L1 is present here, L2 is present here, and R0 is present here. Let's see what is L2 into L2. What is L2 into L2? L2 into L2, it is again R0, right? So it is also present within our group. It is R0 only, right? So it is also present within our group. What about the other elements? Let's have a look here. What is L1 composed with L2? So what is it? L1 composed with L2. L1 composed with L2 is your R120. So that means your R120 is also present within the group. So let's write it down here, R120, and so R120 is also present here. What about R120 into R120? Let's have a look. R120 is here, R120 is here, so when you compose them you have R240 as well. So R240 is also present within our group, because for it to be a subgroup all these elements should be present there, right? Now what about R240 into R240? R240 into R240. Let's check it up. R240 into R240 is R120, which is already present within G, correct? So it is R120, it is already present. So let's check for R240 into L2. What is it? R240 into L2. I am just taking by hit and trial. So you see it is L3. So we have a new member here which is L3. So you see again it is equal to the whole group which is D3. So in both the cases, if you take any two reflections or you take the rotation R240 with a reflection, they again come out to be the complete group, right? So I hope you understood this question well. That is it for this video. Thank you for watching.